Hey everyone, today I'm going to be going over our first homework help video, which is going to be talking about section 8.1 in our book, which was all about exponential models. So since this is our first homework help video, I'm going to kind of go over just exactly what I'm going to do with this. So I'm going to just go over some questions from each little section of the homework. So feel free, if you're just struggling with one or two questions, just kind of skip ahead till you find me talking about that section, and you can just watch that video. So that's kind of going to be how we go about these little homework help videos. So let's go ahead and just jump right into this thing. So the first questions are asking us to graph our function. So for here, I'm just going to make up a different example, and we'll do an exponential equation that looks something like this. Y equals, and we'll do 4 to the x power. So when you're graphing, I want you to go ahead. We are going to graph these by hand, so don't just use Desmos or your graphing calculator. We're just going to make a quick little table. So I have my x's, I have my y's. So you get to choose points. I want you to graph at least 3 points. For exponential functions, it's kind of hard to tell what's going on unless you have at least 3 of these things. But make your life easy. You're going to choose the points. Start with some easy ones. I'm always going to start with 0, 1, and 2 when I do these little tables. So now when I plug these in, if I plug in 0 for x, we're going to get x equals 0. That will lead us to the equation y equals 4 to the 0th power. If you remember our exponent rules, anything to the 0th power just equals 1. So we get our first output, or our first y value. Okay, now let's go to when x equals 1. So when x equals 1, we'll get the equation y equals 4 raised to the first power. So again, this is one of our exponent rules. Anything raised to the first is just itself. So our y value here is just 4. And now we'll finish this up, going to x equals 2. That will lead us to the equation y equals 4 to the 2nd power. 4 squared is 4 times 4, or 16 here. So now for graphing. So we're going to just go ahead and delete our work to the side here. Okay, so we have the points 0, 1, 1, 4, and 2, 16. So build yourself a little coordinate plane. We'll go to the point 0, 1, make a plot. We go to 1, 4, do that again, and then I'm going to go to 2, 16. So 216, obviously I'm not going to be able to fit quite yet on this screen. I'll scroll up a little bit, and I'm going to just do an approximate. It's going to be way up here, and we're going to go to 2, and it'll be about here. So then we're just going to go ahead and make our growth curve. So there is our exponential function. Clearly you can see as we start going up in x, our y starts exploding. So that's what's going to make this thing exponential. Alright, so now let's go ahead and move on to something that looks kind of like question 9. So for this video, I'm just going to go ahead and change some of the numbers. So we'll keep the year the same. We'll say world population in 2000, but we'll go ahead and change this first one to, let's say, 5.28 billion. And then we'll say there's an annual rate of an increase of about, let's go with 1.39%. Okay, so now that we have changed our numbers a little bit, let's go ahead and jump right into this. Part A asks us to find the growth factor for the world population. So the growth factor is going to be derived right from our rate over here. So remember, if you're using a percentage in a math problem, we need to turn it into decimal form. So I'm going to move my decimal 2 spots to the left, fill in our little value with a 0. So we know that this percent as a decimal is going to be 0.0139. That's the decimal form. So the big thing to remember here when we are trying to actually find our b value or our rate of increase, we're going to start out with 100% or 1.00. And then we're just going to add our 0.0139 to that number. So when we do that, we'll end up with 1 and 139 10,000ths. So there we have our growth factor. We are increasing by 1.39%, which looks like this. Okay, now we'll go ahead and move down to part B. On part B, it asks us, okay, suppose we continue to grow at that exact same rate. So we have our growth factor there. It wants us to write a function that would model growth population. So in here, basically our end goal is I want to get an exponential function. Remember our standard form is y equals ab raised to the x. So hopefully you remember from class that a is basically it's our initial point, or it's our y-intercept. So for our problem, we changed it from 6.08 and we said it was 5.28. So there's our a value there. So I'm just going to start writing this thing. Y equals 5.28. And then our b value, that's this thing we calculated in part A. That's our rate of increase. So we'll say 1.0139, and remember that's raised to the x. So there is. Alright, so now let's go ahead and move on to something like you see in question 10. So question 10, we are trying to build an exponential equation, so something that looks like y equals ab to the x power. So basically what we're trying to do is figure out what a and what b are here. So to make this a little different, I'm going to start with the 2 points, let's say 1, 3 and 2, 9. Okay, so at this juncture, we're just going to follow those 5 steps that we did in class today. So the first thing we do, I'm just going to choose one of my points. I'll just choose the first one. And we're just going to plug it right into our equation. So remember, a point is just an xy pair. xy. So I'm just going to plug those right in for x and for y. So first step is going to look like this. We plug in our y value of 3. We have a times b. And that whole thing is raised to the x, or raised to the first power. Okay, once we have this, we are just going to solve for a, or try to get a by itself. So to get rid of this b to the first, I'm going to divide the right side by b to the first. And whatever we do to one side, we have to do to the other. So now I have this equation here that we will use a couple times later on in this problem. So a equals 3 over b to the first. Alright, so now that we've got this equation for what a equals, we're going to go ahead and go back to the beginning of the equation and just plug that into the general form. So when it's y equals a to the times b to the x instead of a, we now have the substitution of 3 over b to the first. We're going to multiply that to b to the x, so now we have a times b to the x. So now we're going to go ahead and use our second point. If you remember from the beginning, our second point was 2, 9. That's just the ordered pair of x, y, 2, 9. So now we're just going to plug those right into our equation. So y is 9. We have this 3 over b to the first times b to the x, or 2 here. Alright, so now at this point, I know it looks like our right side of this equation looks a little confusing. We see a fraction of 3 over b to the first, and we see times b to the second. So let's go ahead and just clean this up. We're going to make that b to the second a fraction by putting it over 1. And then if you remember from first semester, when we simplify polynomials, I have 1b in the bottom. It's going to cancel out one of my b's on the top. So now this equation simply says 9 equals 3 times b. Here we're just solving a simple equation. So we're going to divide 3 to each side, and we get our answer of b equals 9 over 3, or just 3. Alright, so to finally finish up the problem, we now need to figure out what a is. So if you think back to the beginning of the problem, we figured out the equation a equals 3 over b to the first power. I told you we were going to use this a couple times. So now that we know what b is, b being 3, we can just plug that right into this equation. 3 over b to the first, or 3, is just going to get us our a value of 1. And to simply plug everything we just solved for in, we get our final product of y equals a, or 1, times b, which was 3, all raised to the x. And there we have our exponential function. Alright, for your next set of problems, you guys will be working on 16 through 19 and 21. This set of problems should actually go pretty relatively quickly. So on here, the instructions say without graphing, determine whether each function represents exponential growth or exponential decay. So the really only thing we have to pay attention to, we have our general equation for an exponential function, y equals a b to the x. If you remember from class, we defined exponential growth when b was greater than 1. And then we define, so that's growth. And then we defined exponential decay when b is less than 1. So that's going to get us our decay functions. So really in these equations, we don't even really care about what a is. We're just focused on this growth function or decay variable of b. So let's go ahead and I'll do one quick example for you guys, and then I think you guys can kind of take it away from there. So we'll do an example here, ex, and we'll just say y equals, I'll just do some random a, who cares, let's call it 9. And then we'll say b is, we'll go 1.32, and that's raised to the x. So again, we don't care about the a out here, we're just focused on the b value. And I can clearly see that 1 in 32 hundredths is bigger than 1, so we say, hey, this thing is a growth. An exponential growth function. Alright, for your next chunk of homework problems, you have 24 and 26. I'm not even going to go into these again because it's just simply graphing again. So without your graphing calculator or Desmos, you're going to do exactly the same thing that you did in questions 1 and 4 for me. You're just going to make a little table, put 3 points in there, use your x values of 0, 1, and 2, and then just plot those two functions for me. So let's move on to where you guys will be doing 32. It tells you, hey, we're going to write an exponential function for each graph. So what I'm going to do for you guys is I will actually solve 34. So very similar question, just some different points on that graph. So on 34, we're given a coordinate plane with an initial point of 0, 12,000, and a second point down here at 1, 1200. And then it gives me my little decay curve. So on here, I'm only going to use these 2 points. That's all I need to solve this thing. So again, our goal is to get down to y equals a b to the x. So clearly we need to figure out what a and what b are here. So when I actually give you the graph, this is actually a pretty simple process. So if you remember, A really is just our y-intercept or our starting point, which is, hey, right here. So we're going to use the y value there. So I know that A is just 12,123,000. To find our B value, we need to figure out how many times smaller this y value is from our first y value. So what we're going to do is do an equation over here, y2 divided by y1. Or in terms of this problem, we're going to do 1200 divided by 12,000. Hopefully you guys are seeing this already really easily. This is clearly a factor of 10 smaller, so we're going to just get 1 over 10 here. So what that tells us for our equation is that B is this value here of 1 over 10. So now we have everything we need to write our equation out. We've got our A value of 12,000 and we've got our B value of 1/10. So simply our equation is just y equals 12,000 and then in parentheses 1 over 10 raised to the. Alright, so the next section would be question 35. So if you've been watching this video the whole time and you watched question 9, this one is extremely similar. So I'm going to go relatively quick on this one. So for 35, just like I did in question 9, I'm going to go ahead and just change the numbers and we'll walk through. So we'll just say computer valued at, we'll say $5,000. Depreciates at a rate of, let's say, R equals 12.2%. Okay, so the only real difference between number 9 and this one, when we're figuring out our B value, because remember that's our goal, we're trying to write an equation in the form y equals a b to the x. When we're figuring out this B value, I know with the word depreciates that I'm going to be less than 1. So to figure out my B value, I'm just going to simply first put R into decimal form. So we'll write R is 0.122, and I'm just going to take 1 and subtract 0.122 from it. So when I do that subtraction, we will simply get, my pencil, 0.878. So there's my B value. And then if we just remember that A is just our starting value, hey, that's 5,000. I gave you that. So our equation is simply going to be y equals 5,000 and then 0.878 all raised to the x. And there is. Alright, for your last set of problems, you're going to be doing questions 36 and 38. So the instructions say for each function, find either the percent increase or decrease at the function models. So to help you guys out, I'm just going to do question 37. Okay, so in question 37, I gave you the equation y equals 65 hundredths and 1.3 raised to the x. So again, when we're talking about percent increase or decrease, we don't really care about A. What's going to determine this is just our B value here. So all we need to do here, I'm going to take my B value of 1.3 and I'm just going to subtract 1 from it. So when I do that, clearly I just get 3/10 here. So if this number is positive, that means you have a percent increase, like we're seeing. And then we'll just turn it into percent form. Move it over 2 spots, and I get a 30% increase. So if when we did our subtraction here at this step, if I would have got a negative number, that's how you know you have a percent.